Hi everyone. My name is Dmitry. I'm founder and CEO at Emma. So you can see myself here. Yeah, let's start our webinar. So we decided to name this webinar "All the Benefits of Multi-Cloud Without the Complexity," because as far as you all aware, the multi-cloud for everyone means like overwhelming and the complexity. Yes, as much clouds you have, as more complexity you get. So that's why we decided to explain a bit who we are, what we do, and how we can help anyone in this market to overcome this complexity. So let's move forward. The agenda for today's webinar. So 10 minutes marketing stuff about ourselves, who we are, what we do. Then the most interesting part, 30 minutes pure demo of our platform, the product. So I'm showing the platform. You have your, if you have your questions, feel free to raise the hand, ask, interrupt me. So that will work. I'll address all the questions. And also we have the Q&A session in case you decided to keep all your questions somewhere in your, I don't know, notebook, and you decided to ask at the very end of our webinar. So that's the agenda. Who we are. So we are the Luxembourgish company. We've started building Emma in 2019 as a small startup, and we've been developing the product for nearly 3 years. So we released the product in November 2021 during the Web Summit in Portugal. And the Emma platform, where Emma stands for Enterprise Multi-Cloud Management Application, right now is the company of 50 people. We are one of the top 10 strongest European startups based here in Luxembourg. We've recently raised the funds from the top tier venture firms, global venture firms like RTP Global, Altair Capital, and the Circle Rock Capital. And we've been selected as the 500 startups participant back in the days in summer 2020. So right now we're like building a platform, scaling globally. We have customers in Europe, Ireland, United States of America, Turkey, so globally. And our product grows, I mean, really, really fast. Let's click on the next one. So what do we provide at the platform? We have a presence across the globe. So normally it's 150 cloud locations and 50 physical regions, meaning the data centers all over the globe. We do provide the single management panel. So it's kind of a dashboard that eliminates the cloud complexity. So you don't need to be an expert in AWS, Azure, Google, whatever cloud you know anymore. So you just need to work with Emma, and your onboarding process streamlines significantly. So from the days to hours. We do have embedded the migration tools to migrate the workloads from on-premises to the cloud, from cloud to another cloud. We do support the hybrid cloud environments. We do support the cloud native environments. We are purely cloud agnostic platform, so we don't have any lock-ins here. That's why we've built the cloud native networks that physically connect that different cloud environments. I mean, AWS, Azure, Google private environments. So these networks, they help you to scale the workloads, to scale your clusters, to migrate the data. And those networks, which is important, they are 30–40% cheaper than the regular approach when you use the data transfer over the internet. Sometimes we can even reduce the networking cost and the bandwidth cost up to 75%. On top of that, we do support the artificial intelligence for the analytics purposes. So we normally look into the behavior of the applications and the workloads, and we can extrapolate the data, we can do the predictions, we can provide our customers, and we do provide our customers with an accurate data of how much money would our customer be spending on the clouds within the next 3 months, 6 months, a year. So that's one another beautiful thing of our platform. And we do provide those recommendations. So look, we track all the unused resources, forgotten resources, inefficient usage. And we always notify the customers, okay, look, here is the advice to resize the inefficient, let's say, VM to the smaller configuration because you do not utilize so many of those resources. And the other beautiful thing that this is, again, the single platform. So the single service line agreement, the single support team. So you don't need to deal with these different multiple providers, tools, whatever. And our platform definitely supports different sorts of interactions through the dashboard, through the APIs. We have the open APIs, through the CLI that we have our own CLI, through the automation tools like Terraform, Pulumi, whatever you use, your existing pipelines, you can connect to our platform, you can deploy from your pipelines. And on top of that, we also have built in our platform the marketplace of applications, different verticals like DevOps, data scientists, data storage, security, networking, whatever. So from any of these category, you can pick the necessary and required application and deploy it however you want and wherever you want. So that's what we do at Emma. But let's make a short step back and ask ourselves, okay, why people go multi-cloud? And that we believe this slide pretty good illustrates why people go multi-cloud. Sometimes they choose the cheapest provider to test the different hypotheses. Sometimes people go multi-cloud to diversify the risks. For instance, I have my application running at AWS in Frankfurt or in the United States of America, no matter where it is actually. And I want to be sure that my application is always up and running, right? So I prefer to have the redundant cluster where the secondary node, for instance, based at the different provider, preferably inside a different availability zone, or maybe the region itself, maybe the country, different country. So that's why people also go multi-cloud. Sometimes the companies which are built on a single cloud provider, they acquire the other companies which are built on a different provider, and they get this multi-cloud as well. Also for the efficiency. So you understand that the different provider, they have a different services. Some providers, they are better at artificial intelligence model training. The other providers are better in the data scientist presets. They are better on the IoT things and all this stuff. And you don't want to be, let's say, locked in a single provider with a set of tools of this single provider. You want to have all of these tools available for you. That's why people go multi-cloud. And we decided to build something back in the days that actually integrate the cloud management, cost management, and networking management to provide our customers with a single tool that addresses this complexity. And if we have a look on a diagram how Emma actually works, then you see that there is a customer who interacts with the platform through the API or our dashboard, and then with the public clouds or the different services, no matter if it's a plain service based on the bare metal or container or cluster or whatever. And on top of that, those services and those public clouds, they are connected with each other through the networking backbone that we also have invented. And this networking backbone has a capacity of 400 gigabits per second. And this is a guaranteed bandwidth that we provide to our customers. So again, Emma is quite understandable platform. It's a no-code web-based application, and it helps you to create, manage, do whatever you want with your virtual environments within a few clicks. So we can streamline the deployment and scaling of your applications or clusters. And again, it's like a user-friendly platform that everyone understands from the day one. And during the demo of the platform, you'll get this chance to be sure that this is, like I said, quite simple. And again, so everyone really cares about the return on investment. So if you invest in something, you want to get this return. You want to understand either if there are savings or if there are like a kind of a profits. So with Emma, with our predictions, with our recommendations, with our capabilities to track the unused resources or to track the behavior of the workloads, we can reduce the cloud bills on average by 40%, and sometimes up to 75%. Actually, the best case for us, for one of our customers, was 77.4%. So that was pretty significant. And additionally, because it's like simple and understandable and a no code, which is important tool, it eliminates the need to hire the really expensive engineers to maintain the routine processes like the cloud maintenance, right? So we can streamline this as well. And these high-skilled professionals, they could do the different, more interesting jobs and tasks, right? Working on a better tools, working on a more advanced solutions instead of doing this routine thing. And again, so normally when you're thinking about the cloud management and the complexity, you always think, okay, I need this tool for networking, this for security, this for cost management. And here is the one tool, and you don't need any of these other 5 tools to help you to manage the cloud environments. So basically, that's a short overview of what we do. And the next stage here is a platform demo. So I'll reshare my screen and show you how Emma really works. In the meantime, if you have any questions on the first part of what I just shared with you, feel free to raise the hand, drop notes on our chat, or keep your questions in your notebook for the later stages. Okay, wait a second. Okay, you should see my screen now. Okay, that's the main dashboard. So the main dashboard of our platform shows the total cost of ownership of your cloud environments, the number of the CPU that you haven't used, memory, and storage. The projects, so the projects are the level of aggregation of the virtual resources, the services, and the cloud service providers. So for instance, when we click on the Kubernetes, we see that we have the Kubernetes in a single project that we call production, and we have a few cloud service providers underneath this Kubernetes service. So again, the project is a level of aggregation of the virtual resources. We have 2 projects here. We see that we have the number of resources assigned to these projects, the total cost of ownership, and the number of users. So let's dig deeper into the settings. So again, we can name the project anyhow. We can invite the users. And what is important here, the project is a level of aggregation of the virtual resources, meaning the different providers, different services, and we can invite the users and manage the roles of these users and the permissions across all these distributed cloud environments. We can assign the limits to any of our projects. It could be the monthly cost or the number of the virtual resources like CPU, RAM, storage, whatever. We can connect the service apps, meaning we can download our CLI tool, we can use the API documentation, and we can get connected, for instance, Terraform to our Terraform provider. So you can deploy anything in like automation mode to Emma. That's what is cool, really cool about the automation that we have here. Let's move into the summary. So the summary is a simplified dashboard on a project layer that shows you, again, the distribution between the services and your project expenses for the last 30 days. You see all these spikes. You always understand what actually you were using and how much money we were spending. You see here we have the different services like virtual machines, backup, support instances, application, and the Kubernetes, and all these services that can be used in a multi-cloud environment. I prefer to proceed with the cost management part of what we do, and then to the deployment part. So let's start with the statistics outlook. So the statistics shows you the helicopter outlook on all the virtual resources. You see all the available instances, services, providers, and the usage of the resources, the underlying resources like CPU, RAM, and storage. So for instance, when we click on Kubernetes, we see that we have Azure and AWS as the providers, total cost of all the Kubernetes cluster, and all these service nodes that we have here, and the usage of CPU, RAM, and storage. The same applies to any, let's say, other services that we have here. Let's move to the resource overview. We can dig deeper into the resource allocation and, for instance, click on the applications. And then we see that under the applications, we have two applications. Under the applications, we have two compute instances. And we use 3 cores, 9 gigs of RAM, and 153 gigs of storage. And we understand, for instance, that Kubernetes is the most expensive part of our portfolio comparing to VMs. But on the other side, we have more than like 50% of the VM instances, but they are cheaper. So that helps you to understand a bit more your environment and how you actually interact with the different services. Cost analysis, this is something that shows you the real data about your behavior of your environment and predicts your future spends. You can get this information based on all the services like VMs, applications, kubes, clusters, backups, spot instances, or you can choose the specific service and the periods. So that could be the previous week and pretty flat, or that could be the last, let's say, year. Let's do last year. It's 365 days. It will be like this. So that's the historical data. And we see that the Kubernetes cost us 2,000 euros or something. But again, we can also, as I've mentioned, predict the future behavior and the spendings. So let's do the projection on the next month. Normally, those predictions, they work based on the analytics and the real data that we have collected over the period. So if we have a lot of data, we can extrapolate with a pretty good accuracy your behavior of the environment and the total cost of ownership, right? But if we have the limited amount of data, for instance, just the single day, then it will be quite ridiculous to try to extrapolate this for the next few years, because it will be not enough data for such an extrapolation. So here you can pretty clearly get an understanding. So, okay, from June 1st to the June 30th, the total cost of ownership should be around 283 euro for this project, where the Kubernetes is the most expensive service. Sometimes when you do provision, not only the public environments, but also the private clouds, you also need to track the resources that are formally free for you. And that's why we have the resource analysis. Pretty much the same thing, but tighten only to the cloud resources, like cores, CPUs, cores, RAM, storages, so all the things. And it works pretty much the same. So we can choose, for instance, the next 30 days and get an outlook on the projection. And here is the slightly different picture, right? So we know nothing about the costs, but we know that the consumption of the cores will be mostly related to the VMs, but the storage will be significantly related to the Kubernetes. Sometimes that really helps for engineers to understand the complete picture of the cloud environments. So we also have recently added the resource allocation, where you see all the, let's say, cloud service providers, location provider services, all these chains. So for instance, you see that the VM, we have mostly at the G core, the most expensive one, and it's based in Luxembourg. And for instance, the Kubernetes mostly uses Azure in London. So sometimes it's is really cool to have a look on this sort of dependencies, and you can make it in terms of a cost or the CPUs or whatever other resources you'd like to track. And the most beautiful part here, as I promised, we have an advisor. So this advisor recommends you to perform certain actions against the resources you haven't used, either against the application or the virtual instances, like virtual machines. We see that when we deployed an application and we started use this application, this application consumed the nearly all the resources. That's why the advisor tells you, okay, could you please resize this underlying instance into the bigger configuration? The same applies to the next two virtual machines. But for instance, the connectivity VM at AWS tells us, okay, increase the load. Otherwise, you need to delete that because we don't have the smaller instance. And DigitalOcean 1 is unused completely. So here's the recommendation to delete this VM. We can apply all the recommendations. And here's the pure saving over 10.5 euro a month. So just through this advisor. And that's the easiest way to get the savings, just apply the recommendations. Basically, this is it about the cost management part of our platform. Let's move into the services, and I'll show you how this is like easy to deploy the different sort of services, applications, and the instances in our platform. Let's start with the VMs, the most understandable part for everyone, I think, in this room. So look, the VM section shows you all the available instances that we have already created before. So we can manage those instances across the different cloud service providers, no matter if it's StableView or this fancy view. So those indicators, those green indicators, they show you that these 1, 2, 3, 4, 5, 6, 7 VMs, they are connected with each other through our own multi-cloud networking backbone, the one that I told you, where we have the physical presence, where we physically connect the cloud service providers with each other and providing our customers with a guaranteed bandwidth and a guaranteed latency when they connect the different cloud environments with each other. So that's the network, and we show you that there are several VMs connected with each other using this network. We also have these different indicators like red, gray, sometimes we also have a blue. So these indicators, they show you that we have the certain recommendations, and those recommendations are here in the advisor section. And in this advisor section, this one is quite different with what we saw before. This shows you the exact action you need to perform and the reason why. And you can dig deeper into the details. So for instance, let's click on VM detailed info. And then we can go to the analytics and have a look why this recommendation is being advised, right? So we see that there was a significant load of a CPU before, and then we predict, okay, so there's a minor fall here, but then we predict, okay, that should remain the same because something has happened. And the same applies to the RAM. We see that we are using nearly 80% of the capacity. That's why we advise you to perform this resize. And again, you definitely can apply all these recommendations at the same time and get the savings. So like this, it will save us like 15 euro a month. Okay, deployment process. When you click Add VM button, you get into the wizard where you see the providers, the data center regions, the available operating systems, and the hardware configurations. Right now, we have here for the demo purposes 64,301 available configurations. Imagine we are scaling globally. Let's imagine that we are scaling into the United States. Why not? We do think that probably the western part of the United States could be a nice option for us, but we don't care if it's California or Washington or any other western state. But let's have a look. Let's probably move our environment to the cheapest place. So let's click California, Oregon, and Washington. So all those three regions, they are located in the western part of the United States. We know that the average instance that we have, no matter if it's an application or the Kubernetes or whatever, requires a certain version of Ubuntu. Let's pick 20. Then we need to choose the certain version of a hardware. For instance, it could be like 4.16, 128. And here is the interesting thing, that the AWS is the cheapest in Oregon with 111 euro a month, while the Azure in California is the most expensive with 142.43 a month. The same configuration, more or less the same location, same operating system, and you see how different it is. So definitely, it doesn't make any sense. Even if you have the long-term contract with Azure, it doesn't make any sense for this specific reason to use Azure. So you can save like more than 30% here. On the next stage, we need to decide how we really want to build this instance. Should this instance be connected to our multi-cloud networking backbone, or we want to have this instance isolated? For instance, we decided that we want this specific VM be connected to our multi-cloud network. And then we can choose the security group. And yes, we do have the multi-cloud security groups for the different cloud service providers. Then we assign the SSH key here and proceed on the next step. And on the next step, we need to just assign a name. We can add the other VMs. We can add this specific VM into the template, and then we click deploy, and that's it. And the VM will be deployed within like a few minutes. That's the easiest way to deploy the VMs. Sometimes we get the questions regarding the migrations that we can perform, and we definitely can perform the migrations from the public environment to the private environment, from private to public, and between the public environments. So that works really easy. You click on those three points, and then you have the transfer option here. When you click the transfer option, you see all the available options for you to transfer within the region, within the country, within the provider, whatever. So it takes time to calculate the available options here. So, and you can choose the one that suits you, and then you can approve the migration. So that's how this really works. What else do we have about the VMs? So when we click on the VM itself, we see all the information related to the operating system hardware, type of storages, and the networking stuff. And on top of that, we can instantly resize it if we want. We see all the available, we always see all the available options with the pricing tags. So we know the cost of each action, and we can resize this VM to, for instance, this configuration if we want to proceed that way. On top of that, we always know how much money will it cost us if we shut down this or that VM. So that's the other option to save money. For instance, to use our scheduler to put this, for instance, VM on a schedule to be shut down at, I don't know, 7 p.m. every single afternoon. So that's basically it. That's the VM part. Really easy to understand, really easy to deploy. And with these basics, then we can proceed to any other services that we have on our platform. You will catch this really, really fast. So let's move into the applications. Applications, we have our own marketplace where we do have the different verticals like DevOps, databases, analytics, network security, backup. So plenty of these apps. You can deploy any of these apps. And on top of that, you can actually upload your own applications using our API engine. So if you need one, you can deploy those applications basically on the VMs or in the Kubernetes clusters. It really depends on the application. So for instance, if it's ELK, so you can deploy it on the VM. So if it's Redis or Kafka, you can deploy it like in Kubernetes. For Redis, it's either way, VM or Kubernetes. So for the checkpoint, it's basically VM. For the routers, it's VMs. And let's pick something. Let's pick database, MongoDB database. Imagine that we want to launch this specific database using the VMs. Let's start with the VMs, and then I'll show you the Kubernetes stuff. We can enter the name, and then we need to define, okay, do we need a single node, or we want to have the replication cluster? If it's a replication cluster, then we need to assign the primary node using this pretty much the same wizard that you saw recently when we were building the VM. So that's the same wizard, same providers, locations, whatever, but already with the presets, and the number of configurations is significantly smaller because we know the requirements for each and every application, and we already have prepared for you the presets. Imagine that we want to deploy something, let's say, distributed between Bangalore and let's do, yeah, why not? Let's do Bangalore again. So existing key. And the secondary node we'd like to place somewhere in, let's have a look what we have as the node first. Let's do Delhi, maybe Google Cloud. The same thing. So, meaning that once this application, here's an interesting thing, I'll explain later. When this application is deployed, normally in a normal life, so those nodes will be connected. But we have here an important thing, important message. Emma doesn't support multi-cloud, cross-regional, and auto-scale deployment for DigitalOcean and the G-Core because we have recently added those two providers. That's why I've been thinking a bit when I choose the Bangalore, and I didn't know actually that there's only the G-Core there. But okay, so let's pick another instance in a different region, not the G-Core and not the DigitalOcean. Okay, so let's do this one, Azure. That will work. So look, no warnings anymore. We have the Azure in Pune and we have GCP in Delhi. When the application is deployed, those instances, they are connected with each other through our multi-cloud networking backbone. We do the load balancing and all of this stuff. And if anything happens with Azure, or if anything happens with Google, all your data remains at the secondary or the first node. And when we restore the node that has failed, then we do the rebalancing, we do the reconnection and all this stuff seamlessly. So that's how it works. And then when you have an application deployed, then you go to the application center, you see this application deployed. For instance, it was a VM, but we have on the VMs just the checkpoint and the lamp stack. Let's pick checkpoint. You click on that, and then you see that there is an underlying instance, and here is the web UI to the application. So you always can get into the app from the platform. So you click on that, and you have the checkpoint menu here. So you can definitely log in. And here we have the checkpoint. The same applies to any other application. So let's check lamp stack, web UI. We have adminer and we have the web server. So adminer, here it is, the adminer. So no matter what you deploy, you'll always get this opportunity to get into the application. The other way to deploy the applications using the Kubernetes cluster. So you click Add Application, you choose Kubernetes cluster, you choose the cluster where you want to deploy this specific application, the storage, and you can use the namespace, create the namespace, or use the default one. So let's pick it up. Okay. And when you create an application, then again, you have this application that refers to the specific demo cluster. And then we have this demo cluster in our Kubernetes section. And when we get into this demo cluster, we can get into the Kubernetes dashboard. And in this dashboard, there is an application that we have deployed. So right now, that's Redis. And it takes some time to get into the dashboard through my VPN to load everything. So let's wait until it's uploaded. In the meantime, so this is it about the apps. Again, pretty straightforward. You have the marketplace, different set of applications. You can deploy any of these apps, no matter if it's like VM or Kubernetes cluster, and then you can get into this application through the web UI. By the way, here it is, the Kubernetes uploading here. Still takes some time. Next time, I need to switch off my VPN here. Oh, let's wait. Okay, let's proceed with the Kubernetes itself. So look, with the Kubernetes, it's pretty much the same like it was with an applications. You click Add Kubernetes cluster. So pretty much the same UI. Single node, master nodes, you decide how you want to proceed, like this, like that. You can add the master node, again, any cloud service provider. So let's have a look what we have here. So let's deploy something in Europe this time. So Frankfurt, let's do, for instance, Azure Frankfurt. For the workers, let's do something distributed, really distributed between the European countries. Let's pick maybe Netherlands for these purposes. Okay, where do we have the Netherlands? Google, that works. And the cert node, let's pick AWS in Paris maybe. And again, that's pretty simple. So you don't need to be an expert in the Kubernetes deployment. So you just click on it. So here it is. We have the master nodes, 2 worker nodes. Then the magic happens. We can add the auto scaling group here to scale the cluster when the application inside feels that it needs to scale. So click Add auto scaling group. You choose the provider. So for instance, we want to scale with Azure. Location, let's pick Frankfurt as well. And then we'll get the list of available hardware configurations, how we want to scale. So for instance, the top priority for us would be to scale the workloads using the same configuration as we have for the master, so this one. And we put the configuration priority as high. Then, for instance, if we cannot find this sort of instance, then we click on the next one, it's medium, and the third one is low. And apply. So we have here 3 configurations, different priorities, and then we see the settings that we can change. So that should be 1 node. The reserved percentage of the CPUs is 0, of RAM 0, spot instance is 50%. For instance, we are thinking, okay, we want 100% of spot instances as cheaper. Then we click Edit Settings here and go to 100%. And the markup in percentages is 5%, meaning that if there is a price of, let's say, €1 per hour, then we have this 5%, we offer this 5% on top, so nobody steals our spot instance. And we save the settings. And as it basically, so we have the spot percentage is 100, save and close, and we can deploy. And But so we create the cluster, and when the cluster is created, then it's listed here. We have all the information about the nodes. So the 3 master nodes, storage provider, AWS, Azure, and our scaling group. And maybe finally, it's up and running. So, and this is the dashboard. So you click on the Kubernetes dashboard, you get here, and you see that we have an ingress controller, different pods. You see that we have different applications deployed. So everything is here. You can manage either your Kubernetes through the dashboard or using the config file that you can easily download here. So, and using your kubectl or anywhere else. That's it about the Kubernetes. So again, the Kubernetes where you can deploy the cluster in a multi-cloud environment connected through our multi-cloud networking backbone. And you can scale these clusters when your applications, they think they need to scale. So that's super easy. The last but not least here is the spot instances part. I've mentioned those spot instances in the Kubernetes deployment, but for those of you who never worked with the spot instances, I just wanted to mention that there are instances at the cloud service providers, and those instances, they have the reduced price because those instances, they are unused, and the providers, they want to resell them cheaper, but to utilize the entire infrastructure of the cloud service providers. Normally, the hyperscalers like AWS, Azure, and Google, they offer such kind of instances, and you see that the aggregated amount of those instances is nearly the same with the VMs that we had at the very beginning. So here is here on the right, you see the price in tech per hour and an economy that you'll get. So that's the percentage you save. Actually, your saving is 40%. Even for the largest configurations. So let's have a look. The largest configurations here is 48 CPUs, 1.5 terabytes of RAM, and 16 terabytes of SSD. So when I click on that, you get even more, like 45% in savings. Imagine if you could scale your cluster using the spot instances, and you'll get on each node the savings of up to like 45%. Sometimes it goes up to 85%. So for the Google Cloud, by the way, it doesn't show you the economy percentage because it actually works slightly different with the Google Cloud. They provide you with these instances for a limited period of time with already embedded like the good price, but they never compare this to the original instances. So that's how it works with the spot instances. So you're always aware how much money you save on what using those instances for the specific workloads. Normally, you can scale the cluster, and if anything happens, for instance, this specific VM dies or someone stole this VM or anything bad happens, then our platform will search for an alternative instance according to the auto-scaling rules that we had in our platform when we deployed the Kubernetes. So that's the other good thing about Emma that we do. So that's basically it about the spot instances. So the networks, I know that sometimes people ask about the networks that we have. So we do have the security group management. You can create the new group. You can manage the existing groups. So those groups, they have all the rules assigned to the specific instances. And for instance, in one group, we have here 12 instances across the different cloud service providers, meaning that those rules are applicable to all these instances. I mean, inbound rules and outbound rules. So here are all the rules we have here. So, but we can create the new rule. Definitely, we can amend any of these rules like this, or we can delete the security group, but that's not the best idea here. So basically, that's it about the platform. So again, pretty understandable. You can launch different services. You can use in a multi-cloud. You can do the migrations. You can provision the costs. You can deploy the clusters and applications within a few clicks. Basically, that's it. if you have any questions, you can definitely ask me right now. Okay, we don't have any questions. Cool. So, okay, let me switch back to what? We actually been thinking that then we have like 20 minutes to wrap up and for Q&A, but I think we have only one question. You have only VMs and hardware, but what about load balancers, DNS, and all like these features? So that's a good question. Actually, we do have not only the VMs and the hardware, because again, the Kubernetes is not the hardware, but definitely based on the hardware, like serverless requires servers, right? So without the hardware, it's nearly impossible to work. But getting back to your question about the load balancers, yeah, we do have the load balancers, and actually, you can deploy one in our eStore. So let's go to the network. So you can use the hub proxy, Nginx, or F5 as a load balancers here if you want to have an external one. If you use our multi-cloud networking backbone, so in that sense, we use our own load balancers, and we do the DNS management in case you transfer the VMs or the data, or you like rebuilding the cluster on our end. So this is something that we can handle because the Emma itself is a service. So it's not like the platform where you need to do everything hands-on. Hope that addresses the question. Cool. Super. Anything else? Okay.
So a couple of questions from off channel were about the VM migration capabilities. So you briefly touched on them. Can you sort of maybe go back and talk about briefly on the migration capability?
Sure. Let me show you one thing here. That will be something special just for this webinar. So look, we have two sorts of the migrations. So the first one, as mentioned, where you want to transfer the VMs or applications or something legacy, like a legacy workload from your private accounts to Emma or between the accounts. Then you can provision these accounts. Then you can get into the specific account. So let's say AWS, list all the services, no matter if it's like VM, application, but not the AWS related services because we cannot migrate them. Then you click on those environments. So those are the applications, and you can migrate them from the private account of our customer or our private testing account to Emma within a click. So we click add to project. We decide to which project we want to add those instances. And so, for instance, it's production. And then we get this question, okay, do you want to add? And then we need to confirm. And those after let's say 2-3 hours, it really depends on the size of the VM, the number of, let's say, applications we want to transfer, and the amount of gigabytes of storage, so the volume of the storage we need to transfer. So normally it takes from 40 minutes to like a few hours. So we won't be doing this right now. That's the first thing you can do. The other thing you can do, you can transfer between the different public cloud service providers. And this is related mostly to the VMs because you need to transfer mostly the VMs. If you need to transfer the application, normally you put this application either inside the VM or you put this application in a cluster like Kubernetes. And then if it's Kubernetes, it's easy for you to migrate the workloads without any specific tools, let's say. But if you need to transfer any of these VMs, then you click on that. Again, you see the transfer, and then we'll provide you with the list of available options where you can transfer this or that specific VM It could be either the different location or a different provider or whatever. So here, for instance, for Azure, so normally Emma shows you at first the locations at the same cloud service providers because it's cheaper for you to transfer the VM from, let's say, one region of service provider to another. But you can also transfer this from Azure to AWS, from AWS to Google, wherever you want. So that's basically, again, two types of transfers from the private accounts and the private clouds to the, let's say, to Emma and to the public clouds. That's the first one, and the second one between the public clouds when you use this transfer option that I showed. Hope that helps.
That does help. Thank you.
Cool. So we have 7 minutes to go. If there are no any additional questions, it was my pleasure speaking with you today. Hope you enjoyed the demo of our platform. If you have any questions you forgot to ask, always feel free to reach out to our team or to myself through the LinkedIn or any other sources that we have. Like on our webpage, you have the chat that always connects you with the sales team. You can write to our support team. You can use the sales@emma.ms and all these options to get in touch with us. And definitely, if you have subscribed to our newsletter, then please expect the updates from us on a weekly or monthly basis, depending on the majority of an update that we have.